Good morning, students. So, as per VTU syllabus, bending moment and shear force in beams in mechanics of material is unit 5. So, you will get 20 marks full question. So, what all it covers? So, it covers introduction, types of beams, loads and reaction, shear force and bending moments, rate of loading, sign convention, relationship between shear force and bending moments, shear force and bending moment diagrams for beams subjected to concentrated load, uniformly distributed load, UDL, we call it as UDL, uniformly varying load, UVL, and couple for different types of beams. My dear students, what are the theory questions you will get from this chapter? I will tell you with the syllabus. You can expect write the types of beams with a neat sketch. What are the loads and reaction, types of loads and reaction, explain with a neat sketch. Next, define shear force and the bending moment and derive the relationship between shear force, bending moment and rate of loading. These three are very important questions which you can expect from this chapter. So let us discuss one by one how to write theory question. So for writing theory questions, diagrams are very much important and 2 to 3 line sentences is important. So shear and bending moment diagrams are analytical tools used in conjunction with structural analysis to perform structural design by determining the value of shear force and bending moment at a given point of structural element such as beam. So with the help of beam, we can able to find shear force and bending moment. With the help of shear force and bending moment, we can able to find shear force and bending moment diagram. So if you know shear force and bending moment diagram, you know the analysis of beam. Next, shear force and bending moment diagram can be used to easily determine the type, the size, the material of a member in a structure so that a given set of load can be supported without structural failure. So this structural failure is important. As an engineer, you must be very much careful to the word structural failure. So the structure must not fail easily. So for to avoid structural failure, you need to know shear force and bending moment diagram clearly. Another application of shear force and bending moment diagram is that deflection of beam can be easily determined using either the moment area method or conjugate beam method, which you will study in unit number 6, that is deflection of beam. So these two methods are very much important to find the deflection of beam. Next. So very important question as per the syllabus is define shear force SF and bending moment. So the algebraic sum of vertical forces at any section of a beam to right or left of the section is known as shear force. It is briefly written as SF. So my advice is algebraic sum of vertical forces is important. If you know algebraic sum of vertical forces, you can able to find the shear force. Next, algebraic sum of moments of all the forces acting to the right or left of the section is known as bending moment diagram. It is written as bending moment. Next important question is explain with a neat sketch the types of beams. It can be asked for 6 marks or 8 marks depending on the problem given. So the following are the important types of beams. One is cantilever beam, second simply supported beam, third overhanging beam, fourth fixed beam, fifth continuous beam. So cantilever beam, my advice to you is please write the diagram first. You need to write the diagram first in a neat sketch. Below that you explain what is cantilever beam. So you need to define what is cantilever beam. A beam which is fixed at one end and other end is free is called as cantilever beam. So if you write this diagram and if you write this definition, it is sufficient. Next, simply supported beam. So simply supported beam is a beam which is supported at both the ends. A beam which is freely supported at both the ends is called as simply supported beam. So the term freely supported implies that the end supports exerts only the force upon the bar but not the moments. Therefore, there is no restraint offered to angular rotation of the ends of the bar at the supports as the bar deflects under the load. So if you write this diagram, simply supported beam, and if you write that it is a beam which is freely supported at both the ends, it is sufficient. Next, overhanging beam. Overhanging beam is the supports are in between the beam so that the loads are overhanging. The beam freely supported at 2 points having one or both the ends projected beyond the supports. So the beam freely supported at both the points having one or both ends projected beyond these supports. So these two are the supports projected beyond these supports is known as overhanging beam. Next is continuous beam. A beam which is provided more than two supports as shown in the figure is known as continuous beam. See, there are four supports, so if it is supported, the beam is supported by more than two supports, we call this as continuous beam. Next, last beam is fixed beam or built-in or encasted beam. We call fixed beam by other name as built-in beam. So built-in beam or encasted beam. So what is fixed beam? So what is fixed beam? A beam whose both ends are fixed or built in walls is known as fixed beam. A beam whose both ends are fixed or built-in wall is known as fixed beam. It is also called by other name built-in or encasted beam. Please remember this name built-in or encasted beam. Next question.